Are live. um, what is up, YouTube? This is the second episode. Um, my uh, my friends and I are going to solve problems again, and this time we are going over problem 6.1, 7.1, 7.1, variation 1, and 8.1. Guys, let's just explain the problem really quickly, like right before we begin, just because I don't know, it's just like better documentation. So that later
Yeah.
when we watch these videos, we don't have to like go over the problem again. All right, so
Yes.
I'm gonna start sharing my screen. Share screen. Desktop one. Boom. All right, can you guys see my screen now?
Yeah.
All right, cool. So let's go over problem 6.1, and I have it here. By the way, in the Google Drive, I have all the problems, like only the screenshot of it. So if you guys wanna not have to like navigate through the book, you can just come here. All right, so problem 6.1 is just conversion of a string to digits and from digits back to a string, and that's it. So this is pretty much it. So, but we're not allowed to use the Python's inherent stir and int functions. So I'm gonna go ahead and show my solution really quickly. All right. So for string to int, I just use the lookup table. Fairly simple. I just basically go through it. Um, I basically have the string, so I reverse the string. I have this lookup table, and I basically look up the digit. If the digit is less than 0, can you guys hear me? It says my connection is
Yeah.
unstable.
Yeah.
Okay. If the digit is less than 0, I know that basically I start from the end of the string and walk my way back. So if I see a negative symbol, then I will just stop iteration right there and just return negative rval, and this rval is the value that I'm calculating as I'm going through the string. And then uh, I just add rval to digits, and then my tens is basically the number of tens that I kind of keep track of. And that's it. It starts with 1, and then it just gets multiplied by 10 uh, every iteration. It's basically going through the
Yeah.
string digit by
Yes.
digit and calculating the thing. Um, one thing I think, wait, test problem 6.1. Yeah. Okay, cool. Oh yeah, I think I found one problem here with Vlad's solution. So I just like added a test case. Let me just run this test case to see if it passes now. Okay, no, this one is correct. So like both of our solutions work here. But I think for this one, I added one test case where it wasn't working for you. No, sorry, here. Oh no, it works in all of them. All right, never mind. You're good then.
Maybe it's the other problem.
I think it was like this one where like I think this test case was what I added and it was failing for yours, but I don't know why it's like passing now.
Huh.
Is
That's
it
weird.
instantiating yours? Yeah, it is instantiating yours. Anyways, just like be careful of these zeros. So you can have trailing zeros before your negative, and that's it.
Yeah.
Um, and then for into string, I basically just use the same lookup table. Fun fact: if you guys want to know how to do division and then floor, this is basically the operator. So double slash is like division, but also it floors. So that's like
Yep.
the only kind of new thing that I can like have to add here. But that's it. Other than that, like both the
And it's
solutions
very
are pretty.
important in this problem, particularly because you have to make sure that if you make the conversion and you forget to add that extra slash to make it an integer division instead of a float division, then it's going to return a float. That's one of
Exactly.
the, I guess, the little catches in this problem, right?
Yeah, pretty much.
Another catch is in depending on how you solve the problem, but if you're using if you're modding for any digits
Mm-hmm.
to pop the digit, so usually, I guess a common pattern in these kinds of problems is that you can extract a digit, you can pop a digit from a number by modding with 10.
Yeah.
And so,
Well, like least
right.
significant digit.
Yeah, you'll pop the least significant digit with the mod 10, and that's usually very useful for a lot of these sub problems and stuff.
Yeah.
And where was I going with this? That's, I guess, one of the little that's one of the little tricks to this question.
Yeah.
Yeah, no, it's I like your solutions. Your solution's pretty good.
Thank you. So let's go over your solutions, guys. Just 1 second. Let me just.
Wait, one thing just about yours. I don't know
Yeah.
if you noticed, Arjun, but so what you're doing with the lookup table. So your lookup table takes up memory, right? So if you look at like
Yeah, definitely
the
does.
speed of this, it's the length of the string because you iterate through it once.
Yeah.
In terms of like speed, and then the memory is all the digits, so like 10, I
Yeah.
guess.
Yeah.
The memory.
So it's constant memory, linear speed,
Yeah.
linear
And
time.
what
Sorry.
and if you like think about the point of the lookup, well, the point of the lookup table is just to be able to convert from an integer in your case,
Yeah.
or it's a string, and in the other case a string to an integer, right?
Yeah.
And so like technically, what you could do is just use the built-in Python like lookup table of ord or char,
Oh.
and it's the same thing, right? Because that's what the solution ends up doing in the book. But it's like exactly what you did. Like that function ord is exactly what you have there, and char is exactly what you have there, but like for all the ASCII characters.
Oh, that's so nice. Okay, let's just take a look at your solution because I'm guessing your solution uses that too, right?
Yeah. Yeah.
Okay, cool. Let me just get get checkout -b Arshan's solutions 2. Get at everything, get commit blah, get checkout master, get pull. Just want to make sure I get all of your latest solutions. All right, so let's go over Vlad's solution. Tab problem 6p1 Vlad. Boom. All right, cool. So let's see, int to string, iterative int add, iterative using string join, and then this is this ord, right?
Yeah, so that one is it's going from string to int, which is exactly the same thing you have, except essentially just using ord for the lookup table.
Beautiful.
And then yeah, ord is it basically takes it gives you the ASCII value, integer value of a string. And so I just have the offset from 0, and then I just add that.
Nice. That's sick. This is
like
I like the offset trick. That's really beautiful.
So that's like really useful in a lot of any string, I guess, thing to go from that plays around with ints and then back to strings and anything. I just remember from lead code and stuff. I remember this ord thing was beautiful.
Yeah, that's so cool. Damn. All right, thank you. Let's see.
That is a good one.
Oh, another thing that I've noticed here. So I noticed you're raising 10 to the power of this. I think it would be less computationally heavy if you just carried a counter and then multiplied it by 10.
Actually, wasn't that one of the points on the EOPI solutions or whatever?
Yes. So it actually mentioned that point.
Oh.
And it is, I guess, but like technically it's they're still all constant time, but I guess.
What if you like raise 10 to like a really high power? Would it still be constant time, or would it be O of like that power?
Yeah, that's interesting. I guess
I'm wondering.
It is to an extent.
Yeah.
But since we're operating with like only like if it was like small numbers that you're just iterating, like say it was like 300, then you do 3 loops, and that power could be like.
Yeah, it would be like very insignificant, but it would be cool if we could like write a test case where we could see like that if the time actually like grows. Because I feel like if you carry over, if you carry a value where you're like just multiplying it by 10 every time, then that would just be perfectly linear. But in this case, if I give it like a super huge integer, like an integer of like, I don't know, 1,000,000 characters.
Yeah, and then that becomes significant because you have to
this
perform
might
that
become
computation
significant
that many times.
Yeah, over and over again. Yeah, so it'd be like n squared over instead of n.
Yeah.
Because the last operation would be insane.
Exactly. So that's interesting. I'm glad that like it got brought up.
I didn't think of it as much. Like I was like, why are they saying this? This doesn't make sense to me.
Yeah, the way that I thought about it was more from an elegance standpoint. It's like, what's more elegant to read?
Yeah, I love the star operator in Python. It's like it's so nice. I kind of wish other languages had it too. But yeah, in this case, yeah, it's good that it got brought up. Okay, let's see the iterative stir append. Oh, it's like very similar to like what I'm
Yeah,
doing.
it's the exact same thing. I did some really stupid string. The one at the bottom used string. Oh, actually.
No, this is nice. I like how you reverse it here. This is where you're reversing it, right?
I did that. Yeah.
Yeah, you have to reverse it there. Wait, I think I had some realization here because at the bottom one I used string join,
Mm-hmm.
and I think string join was less heavy, or it was better to because every time you append to a string, it creates a new string, right?
Oh. Okay.
Because a string is like a
Immutable.
tuple.
Immutable.
Immutable. Yeah. So every time you append, you're creating new things. But if you use
Yeah.
join, then you're not creating a new thing so if you create a list and then you append to the list each time,
Yeah.
then you're not creating a new list each time, and then at the end you append or you join all the elements in the list into a string, then it's not as bad on runtime. But the other one, if you keep appending to the string, it's actually kind of bad.
Interesting. I doubt if the interviewer would really care about the specifics because it would like be specific to that language, wouldn't
in
it?
every case you're doing any string operation, if you're appending, it's same thing with a tuple. It's much better to like create the tuple at the end if you can, than just constantly updating the tuple, because you're constantly like literally creating a new tuple if you're just adding an element to it or something.
Interesting. So if you call like an append on like a tuple, would it create a new entire tuple?
Yeah, it creates an entirely new one.
Damn, that's so bad.
Yeah,
right.
so that was, I think, because they were mentioning it in the book about that joining is much better than constantly appending because of that, and then I did the two there. But yeah, I think that's something to note just for tuples and strings in general.
Yeah, cool. That's sick. All right. So, Ziad, let's go over your problem, your solution.
Sure. You won't find much of a difference.
6v1 Ziad. Okay. If it's not much difference, then ooh, I like how you commented.
It's not. I think I did a couple of things here. So I did it naively, where you pretty much just pop every digit. I think I call it naive, but it's pretty much doing like the same stuff that both that all of us did. And I also reversed the string here at the end of the function on line 39.
Yeah.
I guess here I like to use a ternary operator just to prepend that negative sign at the end. Yeah. And that brings up a good point, and that is that just a little thing to keep in mind is that mods don't work the same way on positive numbers on negative numbers as they do with positive.
Yeah, that's the thing.
So that's an interesting thing, I guess, to consider whenever you're trying to pop a digit. You have to make sure that you're doing it on the absolute value of the integer and not a negative value, because that will give you the distance instead of giving you the distance in terms of like actual units from 0 to give you that. It does it the other way around. So I'd say that's a little bit of a catch to whoever's watching the video in the future. Keep in mind. Yeah. Hashtag YouTubers. Then I did it. I did a more elegant, like a stir to int, like not in a naive way. Pretty much the same. Like I commented out the brute force way, just to.
I can see that you're using the string. I can see that you're using the string and int operators, like the functions, but you're only using them on one, so it's not. Right? Yeah, like if you just replace one of them with or like look them up from a lookup table, then it would be the same thing. I wouldn't really call this cheating. This is just like being too lazy to like write that lookup table up. But yeah.
Yeah, but aside from that, it's pretty similar. Then I did it kind of just for kicks the same way as the book, which is using higher order functions. I am a big fan of higher order functions in general. I use them as much as I can, even like at work, because they're super, super cool. In Swift, like iOS development, this would be something that you would see in a Clojure.
Yeah.
It's just
this lambda is exactly like that.
Right. Progressively adding on top of what you already have. And that your result at the end depends on a solution of all the aggregate processing that happened before. That's
yeah,
really
that
cool.
makes sense.
I prefer reduce or like higher order functions in general, like math filter over loops, hands down.
Yeah, no, this is cool. I like seeing that. Unfortunately, I didn't really go over the problem solution, so this is all new to me. I'm learning the most here.
Yeah, that's funny. So it's actually a thing. I don't know if you guys feel the same, but I've found myself sometimes in during interviews where I'd come up with a solution and then at the end I would ask the interviewer, hey, like would you propose like what would be your favorite solution? How would you implement this solution? And not a lot of times, it depends if the problem calls for it, but you'd be surprised how often reduce comes up.
Interesting.
Yeah, it does a lot, and it's really, I don't know. Interviewers love this.
Yeah, if they see that you're using lambda functions, it's nice.
Yeah.
Mm-hmm. All right,
so
cool.
Sure. Can I see that one more time? Can you go back to that one just 1 second?
Which one?
How do you handle the negative there? Because I noticed that you pass in.
So you have the sum so far, which is like what you keep track of, and like that gets you every time you go through the reduction. It keeps aggregating on top of that, and then you have the current character that you're executing the lambda function on. So that's char, and then this every time you go through loop or through the reduce is you're taking the sum so far, and then like as it says, you're multiplying by 10, and then you're converting the character to an integer, and then once you're done with that, so the way that I did it here is slightly different from the book. Once you have the result, you kind of like look at there is, now that I think about it, it's like
how do you handle
the first character?
Yeah, what do you do with the negative if the first character is a negative?
Yeah, I probably should have. Yeah, I should have an extra check in there.
I was about to mention, because I was thinking you had like some if statement or something to do for that, but the way the book did it was absolutely beautiful. It was amazing.
Yeah, it was amazing, and I was like, oh man, this looks so complicated.
I did it for all my other solutions that I ever saw this again, but when there's a negative, so like ideally, say you have a negative number, right? Mm-hmm. You want to like you can usually do any type of solution on it by considering it as like the positive thing and then just like applying the negative thing after, right?
Yeah.
So what you want to do is you want to pass in that number, but excluding that first index, right? So what you do is, if you just look at the solution, I think the easiest thing is just go to the textbook and look at
I'm gonna actually pull up the solution here.
Yeah, go to page 59 in the textbook.
6.1. Wait, what's this? Line. What's this? 6.1, right?
Yeah, that was it. The very last line.
Yes.
Yeah, look at that very last line, the very left of it.
Oh, sorry. This is a little low resolution.
It's okay. So what you're passing in to the lambda function there is you're passing in the s, which is the string, right?
Mm.
And the index starts at 1 if the first value is equal to negative, right? Because so if the value at the first index is equal to minus, then it equals 1, which means you start at index 1. But otherwise it's 0, so you start at index 0. So that's how they say what elements to use in the actual string, if you see what I'm talking about there.
Interesting.
It's so good. It's so well done.
It's so beautiful. I was like,
it's so beautiful. I agree 100%.
I don't know how readable this is, though. I mean, like maybe to someone who's like worked with a lot of lambda functions like all day, then this is something beautiful.
Like it's not lambda specific at all. It's just because this is actually first of all that's related to the function tools that reduce, because just the input value. So like what Ziad could have done the exact same thing with just by passing in that exact same. It's just setting the limits of what you pass in depending on what the input is.
Yeah.
So it's not like specific to lambda or anything.
No, it's not. It's not specific. I didn't mean it that it's like specific to lambda, but this is very kind of like a functional programming-esque of like writing your solution.
Yeah.
You know, you don't have any variables. You just pass in functions inside functions, or like you pass in like you basically have this like one really cool if statement thingy, or like a ternary operator that passes the first index. But your entire thing is just like, tends to be like one-liners where you just pass a function into another function into another function. That's like the whole point of like what's it called, the functional programming paradigm.
Yeah.
But yeah,
exactly.
That's cool.
And it's also a bit of thing with Python. A lot of Python solutions are known to be one-liners a little bit.
Yeah,
so it's like oftentimes the Pythonic way of doing things is something that requires knowledge of the language over like more than just beyond the amateur level. So I find that Python does that. Like it happens a lot with Python.
That's true. Mm-hmm. All right. So do you want to go to next problem or anything else you guys have to add?
Let's do that.
Not really.
Okay, sick. All right, 7.1. All right, 7.1. Let's go with Vlad's solution first. All right, Vlad, you want to elaborate?
Yes, so this is very simple.
Oh, wait. Let me go over the problem first. So problem 7.1, very simple. It's the classic merge part of the merge sort, pretty much. You have two linked lists. Each one of them is sorted. That's a given. And then you just want to return a new linked list that is also merged using those two. That's it.
Yeah. So it's very, very simple. We will have two variables. One that's just a pointer to the very start of your new list. Yeah. And we're going to keep that throughout the whole solution so you can return it.
Yeah.
And then the other variable is just going to be at the start, and then it's just going to iterate through the list, basically constantly updating your new sorted list. And so, we keep looping until we're done. Mm-hmm. And in the loop, we check for if both lists exist, then we do a check to see if the value is less than the which of the two list elements or the linked list elements is smaller between the two linked lists, and then you update like accordingly, I guess. You just basically move your sorted list pointer up at one, and then you move the pointer of the list itself up one as well.
Mm.
I mean, right. That's and then you just keep doing that. And then once one of the lists is done, you're going to see that if linked list A and linked list B statement is not going to pass. And so basically what you want to do is you want to append the rest of the other list to the solution now.
Yeah.
Or to the list. And so the way I did that is kind of ugly. So the way I did it, I did a check like else if the list A is the one that right after that if statement at the kind of the bottom there. Else if linked list A, if that still has elements, then you just append that to the rest of the list. Otherwise, if linked list B still has elements, then you append that to the rest of the list, and then after that you just break, and then you have the solution.
That's nice though. I mean, I like the fact that you're doing this list that next is basically the head of the other list.
Yeah, I mean, so that's pretty. At least I'm not like looping through it and constantly adding the elements.
Yeah,
exactly.
But the book does an even more beautiful thing. They just simply say that sorted list next is equal to list A or list B, because one of the lists is going to be completely.
Oh empty. My God, that's beautiful.
Yes. So I was amazed. I was like, this is beautiful.
Yeah.
So yeah. So I ended up using that for the variation one, but yeah.
That's sick.
Anyway, I think
that is so good. Yeah. Now that you mention it, it's like it's such a better way to write it.
Yeah.
Yeah, I was so impressed constantly throughout this book, because there's so many times where I like write things out so like verbosely, like if this, else if this, else if this, and then like you realize there's so much, like even using the max function, like if you check if something's greater than that, you can just update you can just do max of the two elements and then set that value. There's a lot of like.
One advice that I do have though, it's like I actually saw this. I heard this in a Google interviewer told me this. He was like he was basically giving tips in interviewing. He was basically saying like just write down the first thing that comes to your mind. It doesn't have to be pretty, and then you can clean it up. So these are really nice when you like read the solution of the books. They're just like all like very to the point, concise, and like very short, but like the goal of this in these sessions is for us to get comfortable enough so that we can even like come up with those in the first solution. But if you can't, it's totally fine. Like just like you can basically just vomit whatever it comes to your mind first, and then you can clean it up. And the interviewer actually appreciates that, the ability that you can clean up your like mess.
Yeah, and I don't
think it's part of the problem-solving process.
Yeah, I don't think first run through the solution you would have such a clean thing, but you once you keep doing these type of problems and you notice these kind of cases where you're you do two if statements to check if things are empty.
Yeah.
Then you can realize when you're actually doing it in an interview that you can just do the or thing afterwards, when you're looking over it one more time to clean it up.
Exactly.
Yep.
But one thing that I'm a little bit curious here is why did you? I mean, here. Simultaneous list block, you are these variable names are list A and list B, whereas they're not really linked lists; they're just list nodes.
Yes.
Yeah. So that was just one thing that I noticed.
Oh, because I did a dumb. I don't know if you saw the whole thing, the way I did the whole problem, or the way I did the protocol.
The protocol was a little weird.
Yes, I don't know why I did that, but I did. And then I made a linked list class that was basically. That had the head pointer, so it was technically a full linked list and had functions to operate on it, but all you really use is the head and then traverse anyways.
Yeah.
So that's why, but then I still pass in just the head, so it doesn't matter. If you look at the test case, I realize I am just passing in the head, so it's not even a linked list; it's just the head node.
Yeah, exactly.
So I named it poorly.
Yeah. Okay. Yeah, that's fine.
I realized afterwards.
One thing that I noticed that you didn't add here is in your assertion. Here at the end, you should assert that your actual head is none. Because because you exhaust your actual head, right? And then you don't assert that you've exhausted your actual list yourself. So if I, for example, delete this. This will fail, whereas with the way that you had your test case, it would have passed.
Oh, because you didn't finish adding all of them.
Exactly. So look.
Yeah.
It passes now. So that's just one thing that I noticed. But I changed this up a little bit. Actually, this is okay. So if you have anything else to add, I can move on to how I changed this up a little bit. But I have to switch the branch.
No, I'm done.
Alright, cool. Let's go. Running out of time. It's okay. We're not gonna do much more. Okay, let's go here. Check out this. Alright. Get slash get check out. Alright, so I changed this up a little bit. Wait. This didn't update. Oh, okay. There we go. Now updated. So, my solution is not as nice as yours. I really like that. But what I did was that I was just thinking differently. So I just passed in the list nodes. While this is not none or that the other one is not none, I would just push. But I made a merged. So this merged is a linked list, and then I added a push to the back of the linked list method that basically just pushes to the back.
Yeah.
And then I just did merge dot push back b.data blah 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 blah, and then at the end I just went through the rest of the list, which is the ugly part. And near the end I just had to return head because of the way that the test was set up. But one thing that I noticed that we can do here, which would have been kind of cool, is so I just added this toList method to linked list that just returns a normal list representation of that list.
Instead of doing that nice look at the test.
Yeah, so this way this becomes just a simple assertion, because when you do assertion on two lists in Python, same thing here.
Yeah.
So I just added this because this one was returning a list node. Then I had to just add this node to normal list function that basically does the same thing, but it takes a list node as an input. Therefore, and because of that, these became much nicer. And when your test fails, it's nice because it basically tells you it was asserting that this list was equal to the other list. Whereas the way you had it, it was basically telling you, oh, this value at this node is not what I'm expecting, which requires you to kind of like go through and step through your code and see exactly what's happening at every single node. Whereas like in the other one, it just kind of gives like you passed in 1 2 3, I got 3 2 1. This is wrong, which is like a little bit more input outputty. But yeah, that's all I have to add. But your solution was beautiful.
Yes. Oh, and the other thing I think I noticed at the top. What the hell? Can you go up? I think I wrote some stuff at the top about the testing.
Needs better naming convention.
Yeah, we needed a better. I couldn't decide on the naming convention for testing, like when I define classes in the protocol for the problem. Because I wanted to test like create linked list, but you don't know if create linked list is like from the problem or if it's just testing that the actual create linked list from the class linked list works. So I didn't know what the best way to name this stuff was.
I mean, honestly, whoever does it first gets to, yeehaw it. I mean, I wasn't I didn't really have much problem with the way you set it up. If anything, it was nice because I had to do less thinking and everything was defined for me.
Okay.
So, I mean, I had no complaints. What was weird to me was the fact that you were just passing head and we didn't really need that entire linked list data structure.
I realized later because I did it. Like I didn't want to like look at anything online, and then I googled like how people usually and they just define like all the methods within just the linked list node.
Oh yeah, that makes sense.
Which makes a lot more sense. I did a similar funny thing in the tree stuff, I think. So when you get to the tree questions, you'll see what I mean.
Okay. All right. Ziad, let's go over your solutions. Or if you... Sure. Okay, let's go. Git checkout master.
I've only got one thing about my solution that I think maybe would add something. It's not that different from Vlad's. The main thing is that I reserve the two if checks. If I remember correctly, what I did was, so I went through the loop, and that is until both, and for as long as both the, so that's 7P1.
Yeah.
Is that, I'm not even seeing, oh, okay, sorry. Yeah, so, yeah, you pretty much go through both lists. So I did a brute force, I guess. I thought about the brute force. The brute force would be just take both lists, append list 2 to list 1, and kind of do a sort later, like one of the built-in ones, and then a merge sort, and that would be a O of n log n, which is obviously not efficient as doing it yourself. And I think if I were to go through an interview that asks this question, that's the first solution that I would provide. Just like I would just say, so the first thing that I think about is just appending one list to the other and then running a sort after that. And then the way I would improve it is just by going through a while loop and then building my own list until as long as both lists exist. And then when one of them is exhausted, then I would check which one is not exhausted. And I would append that to the new list that I formed. And I think the difference between my implementation and yours should only be the fact that I put the if checks after the while loop. But I think you had a break or something in there. So same thing, pretty much.
There was no reason to. I like the way you did your, and you also did what, like you didn't have the stupid if one. But although honestly, like doing the while trues, doing the while one or while trues, kind of allows for like I actually do. I feel like every time I do these type of things, I just do a while true and then I do all the checks within the loops. Yeah. Within the loop, and then after that, I'm like, oh, I can just do it within the while loop. Like
yeah, I mean, it's a matter of taste, in my opinion.
Yeah, my opinion about like it's funny because if you like logically speaking, I don't really have anything against the while true, while one, or whatever. But for some reason, there's something inside me that says do not use those loops. I don't know why.
Well, I mean, like it does leave some kind of room for an infinite loop, but
yeah, I guess that's the Yeah, but I mean, there's nothing wrong with them. Like logically speaking, they're as good as any other method as long as you handle all the edge cases properly.
Yeah. Because realistically, when you do this while list 1 and list 2, it's essentially while true, and then having a wrapper that says if list 1 and list 2, and then you do the stuff you had in there.
Yeah.
Exactly.
So if there was 2 checks you wanted to do, then you can't with like the while thing there.
Yeah.
It's a while true.
Yeah.
Yeah.
That's fair.
Anyways, I think we're good.
We're good? Okay.
We're pretty good, yeah.
Let's move to the next problem.
I think this one is very interesting. Actually, I don't know, all of them had some like interesting.
AP1. All right, so problem AP1. Let me go over.
This one.
Actually, guys, do you want to move to a new call?
Sure.
Oh, sure. Let's do that.
All right, let's just do that, and then we'll go ahead. All right, let's invite, copy invitation. Group chat. Where's our group chat? Messenger. There we go. Group chat. Nice. Let's wait for them to join. There we go. Manage participants. Hello.
Ding dong. Hello.
Let's wait for Vlad to come. I actually got super lazy for the next problem.
Oh, this problem was probably the most interesting one out of all of them. And the main reason is this. So, we obviously we practice algorithms because they're good for interviews, but we don't really get to use algorithms in most cases.
Yeah, that's true.
And from day to day, right? But when it comes to data structures, like ADTs, data structures that you're making out of simpler data structures and then kind of building up from there are amazing because those you get to use a lot. And those are such a fundamental part of good architecture within software that it's a must. Like being well versed enough to understand why you're making a choice over another, and you have a lot of choices when it comes to making your own data types. It makes a difference between a super efficient solution and one that's not maybe as efficient, and it's such an interesting concept topic in general.
I agree. Oh wait, sorry, I'm not sharing my screen. All right, can you guys see my screen now?
Yes.
All right, cool. So let's go over the topic of this problem. 7.1 variation 1. So the variation is the variation is solve the same problem when the lists are doubly linked. So I didn't really add anything here. What I did, let me actually just show you what I did.
Yeah, there was 2 lines or 2 things to change from when I was looking it over.
Oh, let me show you my solution because it's like really lazy. All right, so I basically took the last problem, and then I just set the previous on the node.
Oh yeah, but you do 2 loops, right? you do the loop for the original, and then you do the loop again there.
Yeah, which is basically O of 2n.
Yeah, which is still fine.
Which is fine, but I was trying to get ready for this meeting, so.
Yeah, no, it's fine.
Let's go to Vlad solution. R7 P1 var1. Let's go to Ziad solution because it came up first.
All right. So what I had here, and it's pretty much. So I haven't really done too much testing on this. I've come up with a O of n runtime and O of n plus n space solution. Well, O n plus n where m and n are just the number of elements in list 1 and list 2. And the only really thing that I could think about in terms of the difference is, well, a doubly linked list is the same as a singly linked list, except you've got every node has a pointer that points back to the previous node. So I'm like, well, then all I got to do is change the pointer of as I'm setting new nodes, as I'm going through and building the list. Well, all I got to do is point back to the previous node. And then I use the exact same pattern as before, where I've got list 1 and then I've got list 2. And I'm setting the forward pointer and the backward pointer, and then incrementing the list. Whatever list I've gone through, I go to the next pointer there, to the next node. And then I check if list 1 is empty. If this one exists, then that means we ran out of, list 2 doesn't exist anymore because we went through all the values of list 2 and appended to the new list. And then if that's the case, then all I got to do is just go to the next pointer and then also set the previous.
Yeah, next dot previous. Yeah, I can see that here. All right, cool.
Because if you don't,
if anything, this just seems like more work.
Yeah, well, the idea is that obviously you guys already know this, but with doubly linked lists, you get benefits that you wouldn't get from singly linked lists. And I think it was faster access to other, or faster removals, so that they don't have to be. I can't remember, but it's one of them. And it's faster. You get an O of 1 instead of O of n.
Yeah, I remember that, because to get the last node, you would basically have to start from head and move all the way to the last node.
Exactly, all the way to the tail. But
So to remove some node, if you're given the node itself, then it's O of n, because you would have to move from the beginning of the list to that node.
Yeah.
But if you want to remove after a node, then it's super easy. It's super fast.
One thing that I would change here that I saw, I can't remember if it's from your Vlad, is that you guys are do this thing where you assign multiple variables on the same line.
Yeah.
And it's something that you do in Python, but I haven't done in other languages. It's so cool. It's a better way to.
Yeah. If you look at mine and you put Ziad's right beside mine, you'll notice that the way you do it, you have to do it in the correct order as well. So the way you have yours, the 3 steps there, has to be a one-liner, but the steps of which you set them have to be the correct order. So you can see in your case, for you the dummy node is technically your sorted list, and for me sorted DLL list, doubly linked list, is the dummy node, and you can see the order I do that is exactly the same as your order, and it has from left to right there, and it has to be in that order, because if you do it in another order, it doesn't make sense. So
right.
It does exactly what you're doing in that order.
I guess the only thing that would deter me from using a one-liner solution, but it's a really small thing. It would be a readability thing, but even then, it's not really a good reason not to use it. I guess going through the assignment here and saying I got to look at the first. If I'm looking at the first variable on the left-hand side of the equal sign, then I got to look at the first one on the right-hand side.
Oh, it's so annoying to read. It's so annoying to read. I know when I actually look at the solutions in the book sometimes, and I'm like, what the hell are they doing? I just rewrite it in the right order to make sure. So I'm like, okay, this gets set. Now this gets set. Because it's very
totally agree.
Now, on the plus side is you get a much shorter function, which I do like that, to be honest. I think I'll start using this inline. I don't know if it's called inline or whatever assignment, but it's kind of.
I don't know.
Cool.
I still honestly don't know how I feel, because it's I feel like it's only to the people that have been using it enough in specific cases that know that this is really useful for. But honestly, I feel like in the general case, especially at any company where you're having random people looking at code, it's
right.
It's honestly, I feel better to write it just verbose.
Yeah, it might do more harm than good.
Absolutely.
Yeah.
Oh,
because
100%.
It's just such a strong it's just kind of to show off, but I don't feel like it's actually useful. This is not great.
Readability leads to better maintainability of code, because whoever has to maintain your code later, one day you're writing the code today that one day will be legacy code, and you want to make sure that whatever the future programmers are reading is something they can get to without having to, read up on the nuances of the language. And I think it's, I agree with what you're saying. What I do like here is, I think you talked about this, but how you'll append the next the list based on whichever one is not none, and it's such a clean way to do it.
Yeah, the or. The or is such a, yeah. Because basically you have those two if statements, and the or makes it one.
Yeah.
Yeah. And it's just as readable. So it's one of those cases where
even if it's good on
code,
both
I would
sides.
totally go for that.
Also, one more thing I noticed in your case is you have dummy node next previous equals dummy node, which is run in the both if cases.
Yeah.
So you could have just put that outside the if statements, both of them.
100%. Yeah.
That's fair. Yeah. Interesting.
Yeah.
All right, next problem.
Yeah.
Alrighty.
Let's go. This one's my favorite. I don't know if you guys were talking about this when you were saying like this one was
All right. Was the variation.
So this is the problem. Design a stack that includes a max operation in addition to push and pop. The max method should return the maximum value stored in the stack. Hint: use additional storage to track the maximum value. All right. So let's go over problem AP1. Vlad. All right, Vlad. Do us the honor.
All right,
do the honors.
Went straight to one. So one of the solutions, and that's the only one I did. So I only have one. And the solution was to basically keep track of the max every time you add or I guess the logic was, first of all, I was like, okay, I'll just have some variable to keep track of the max. So every time I add a thing, I'll just be like, okay, this is the new max, this is the new max. But then I was like, shit, when I pop. And if I pop the max, I'm fucked. Because then I don't know what the max is anymore. So then I have to loop through the list and update the max. And if it's like, in the worst case, it could happen every single time you pop. So that's like really inconvenient. And then I realized you can just have data, like a new data structure for each element in the stack that has the value and the max. As you can see, I call it stack element there, whatever. And yeah, so then I just not only store the value on the stack, I also store the max at the current level of the stack.
Okay, cool.
Yeah.
And so then every time you pop, you just check, is this max the current max? No, wait. Yeah, no, you can just pop it.
Yeah, you can just pop it, yeah.
I think you just read the corresponding, like the next peaks, corresponding max.
Yeah. So then there's one thing. So I'll just go over what I guess my issue was, because then the book mentions that this can be done even better, and I was like, what? But then it makes sense because like technically, imagine the first element you add is the max, and then the next ones are all not the max, and you add like a million other ones. Yeah. Then you don't want to waste storage on storing the max value for all those other elements every single time.
Yeah.
After.
Yeah.
So what they do is, instead of storing the max as like another value or
stored in a lookup table of the index where it changes, where the max changes.
Store it at the points where it changes and not when it's the same. Yeah. Go ahead though. Like,
sorry. Yeah, we cut you off.
Yeah, no, those are actually good. I'm thinking because you could just store, but how would you store it only when it changes?
Oh, it's just in the index into your list where it changes.
So, but you'd have another list of indexes where it changes, and for those indices, a corresponding value?
No, you have a lookup table where the keys are the index at which it changes, and then the value is the new max value.
Oh, yes. That's actually pretty good, I think.
It would not be really space efficient if you have already sorted list, because your lookup table will be index 1, this is the new max value. Index 2, this is the new max value.
It doubles it, right?
Yeah.
I mean, you have a key and a value for each time now.
Yeah. So you have a key value, and then you have your original list. So
Is there any harm of that when there is multiple of that same max value? Like if there's a max... No, you can just do a check.
No, because the max value doesn't change. So you just assume that it's the same thing. Oh, sorry. Wait, what were you saying?
Oh, because you have a variable that's the current highest max.
Mm-hmm.
And then... Oh, wait. For that lookup table, how you can't have the keys as the index, because then to figure out the max, you'd have to go through all the keys.
Well, no, you can keep another variable of the largest index.
But as soon as you pop that largest one off, you have to go through that list again, or through that dictionary again to find the max, right?
If you pop, then you have to keep track of the length of the stack. And if the length is less than the max key, like the last index at which it changed, then you basically just delete that index into that entry table, and then update that index to be the. Oh yeah, you're right.
No, yeah, but I'm
just. But that one you would have to go through the list.
Yeah, because that's annoying. Yeah, and then the dictionary doesn't have any order, so you can't have it like as the last element in the
Actually,
dictionary.
you can keep an array, a sorted array, because like, I mean, you can basically keep an array and then push onto it, and then you can push a tuple where the first element of the tuple is the index at which it changes.
Yep.
And then the second
like
element.
You push, yeah, that's it. That was one of my
solutions. Now we've gotten to the solution that they propose.
Oh, really? Nice.
Or an array where you push the max, like as you add elements, you push to it if it's a max or equivalent to the max.
Nice.
And then so the stack will always be the lowest value, like the lowest maxes, and then if there's a bigger max, then it gets put on top of the stack, obviously.
Yeah.
So what they do is they keep a tuple, like you said.
Yeah.
And the tuple is the value and the value of that max and the number of times it occurs, because you don't actually care about the index.
Oh yeah, you're right.
Because when you pop, you just check, is it equal to that current like value in that other stack that keeps your max, or is it not?
Yeah, it's a cleaner way of thinking about it, actually.
Yeah, and then so you have a count for how many times that max has occurred.
Yeah.
So that's how they did it. But then I thought, why would you do that? Like, because what they mention actually in the book is they're like, note that. Oh wait, let me just read that line because I was confused by it, and maybe you guys can clarify. Because I thought you could do it slightly differently. My goodness. Am I just scrolling? I could just search.
Oh, is that the sound of you scrolling?
Yes.
Jeez.
I was like, is he scratching his head or something?
Aggressively scratching his head until his hair falls out.
Oh man. Okay. So here they mention this. They say we can improve the best case space.
Wait, why are you scrolling? I have this.
It's okay. They say by improving the best. Yeah. Wait. No, it's the next. It's the page above it.
Oh, okay. It's this one.
Yes. Okay. So.
Here we can improve on the best case.
Yes. So it says we can improve on the best case space needed by observing that if an element E being pushed is smaller than the maximum element it's already in the stack, then E can never be the maximum, so we do not need to add to keep that record. We cannot store the sequence of maximum values in a separate stack. So this is the line that confused me. We cannot store the sequence of maximum values in a separate stack because of the possibility of duplicates.
Yeah.
So I didn't understand why that's a problem, because if you get the same, like if you get the max again, you just pop it on that stack again, and you'll have two of them. You can have duplicates. So they say we resolve this by additionally recording the number of occurrences of each maximum value. So they basically, if you go down, or if you go into the other picture, they show like the pictorially what the other stack looks like.
Yeah.
And you can see the stack to the right of each of these pictures has like the value and then the number of occurrences. So I didn't understand why for like, let's say the picture to the very right there, the top very right, where it has the 224152.
Yeah.
Why that couldn't have just been a stack with two 2s at the bottom, a 4, and then 2 5s?
I think it could have been, honestly.
I think so too, because I'm just confused.
I'm just saying, I totally agree with what you're saying. But wait.
Now, there's one harm I see with this, which is not like a thing that it can't be. It's just that, like, say the max, the duplicate occurs 1,000,000 times. This is only 2 values to store that. While in my case, you'd pop 1,000,000 values on the stack.
Exactly.
Yeah.
You would it would be less memory efficient. It would still be better than keeping the max with max so far at every single node.
Only in the case that the max occurs twice or more consistently. In the case that the max is very sparse and it's very common that there's only one occurrence of it, then storing two values as a tuple is much worse than just popping it or pushing it.
Yeah.
I agree. Could it be in case we have duplicates? So what happens if we've got a max that happens at some point, then you've got a bunch of other numbers that are not maxes, and then that max is there again. Yeah. Then, I mean, we're keeping to add. So can you guys still hear me?
Yeah, it actually got better.
Nice. That's not good news. But okay, so let's say you encounter the max at first, and then you encounter like other numbers that are not the max, and then that same number again.
Yeah.
You have to go through the max, the auxiliary stack again, and does that have an impact on? Maybe not actually. No, actually, never mind. Yeah, there must be a reason. And
I couldn't think of it.
I mean, the reason, I think Vlad just talked about it. It is less efficient if you have too many maxes that occur. That way, your stack basically grows to the number of maxes, whereas like keeping the max and the count is like much more efficient. But if you have more sparse maxes, the Vlad's proposed solution would be even better because you're basically keeping two maxes, whereas here you would have to have two basically data elements in every single entry of your stack.
The way, perhaps the way the book kind of like the way it read was that you couldn't do it because you would encounter a case where the implementation would break.
I don't think it would break. I mean, like the book does say it like that, but I can't see why it would be broken.
Yeah.
It says because of the possibility of duplicates, but
we cannot store the sequence of maximum values in a separate stack because of the possibility of duplicates.
No, I think it's okay.
I think so too, because they do the exact same thing.
Yeah.
It's technically the same thing.
Well.
All right. So okay, cool. This is Vlad's solution. Do you have anything else to add, Vlad?
Nope.
All right. Let's go to problem 8P1. Ziad.
All right, so this has got a lot of stuff commented out because I kind of went through like all the approaches that I could think of, and looking back, this is a little bit messy. So one way, I guess the brute force way, the way that I thought about it, and I don't have too much to add on top of what Vlad said. I kind of like adapted some stuff from Vlad's API when I realized that the tests were failing because like I had to have a certain my data structures like data structure kind of organized in a certain way. But yeah, so the way that I thought about it was this. So the brute force approach would be to naively always calculate the max every time you want to know about the max, and that would be an O event every time. So that's kind of the basis. A more elegant way to do it is to reserve extra memory for a variable that keeps track of the max, but this is stateless. And so the problem with that is that whenever the state changes in a certain way, aka you delete or you pop an element, then you have to that's when you have to fall back onto your naive way of calculating the max because you're not keeping the state. How do you solve that? Well, you do that. One way to do it is to add a list of tuples, because that is stateful. So every time you add a new or remove an element from the stack, you know that you're keeping a state of the maximum up to that point. Then another approach is the two-stack approach, which I don't know. Was that the one that Vlad did? I can't remember, but those are the four approaches I thought of. I'm trying to think of things that Vlad didn't talk about that I could talk about.
What were you saying about how? What was wrong with the testing that you had to implement your thing differently? Because I think all you needed was a max function, right?
there was something. Was there something else? Maybe I can't remember. There was. I did some quick testing today before the call, and it was something was failing. So I was like, oh shit! And then it's probably because I didn't have like create max. One of the things was I didn't have create stack in there, and so I kind of added it to it. There were a few things that were failing, so I'm not sure if it was the protocol or like rather the test harness, but something in there wasn't liked.
Oh yeah, I put a lot of tests for the other functions too, like push, pop, pop when empty, max, max when empty, max with push, max with pop. Oh yeah, I think you only needed a max function. You didn't need those ones, but I don't know.
Yeah. I could have just removed them. Yes.
Okay. So wait. So my solution. Wait. Get check out. Version. Okay. There we go. All right. So in my solution, the only I don't think this updated.
I think you have to stash again.
Problem AP1. Oh wait. Yeah. Get stash. All right. There we go. It's changed. So the only thing that I did is that so you had while stack because it was assumed because I was just trying to solve this problem really quickly. So this stack is basically a variable that holds a list. But one thing that I did here, I mean, my solution is not the most efficient. I basically have like the push and pop and all that stuff, but I didn't really know if I had to use a linked list or like a normal Python list here, which is why I kind of like did it with a linked list. But one thing that I did is that I think could be like an additional thing to kind of add to this conversation is this stack with max class that interfaces the solution, like the test. Subclass is a linked list implementation of the solution. So I could add another class here with a different implementation, and then that solution, and then just like change this one line to have the test interface that.
Yeah,
so that was some like abstraction kind of abstraction magic there. That
I was going to mention that same thing. I think Ziad could have done that for all 4 of his solutions, right? You could have 4 classes for each of the solutions, and then just change the one one over there with where the final class, the stack with max subclasses, which one of the 4?
Yeah, I see it. Yeah, I could have. That's interesting.
I saw exactly what you did, and I was like, I wonder what the cleanest way to do this is.
Yeah, it's because you kind of want to keep all of them like it, but I was like, you know what? It's just for like our own knowledge, so just keep them all in there. But yeah, no, I like this. It's good.
And then pretty much this. But this is the naive solution. So find max. I just look through the list for the new max value and just update my max value to that. But yeah, nothing else to add here. Does pass the test though.
That's all you need.
Yeah, exactly. All right, cool. Thank you so much, guys. If we have anything else to add, we can talk about it. But if not, this has been amazing. I think we're already over an hour.
Yes.
So we're only 4 problems.
That still gets longer than the previous one.
Yeah. No, actually, the previous one was still longer.
Oh, nice.
Yeah, that one was like 2 full 40-minute meetings.
Jeez.
Yeah. Anyways, thank you so much, guys. I'll put the next problems in the group chat, and then we can like go over them.
Yeah.
All right. Sick.
Guys.
Stay home, stay safe, and see you at next episode.
Are we doing Saturday?
Wait, what? Yeah, Saturday. Like the same time. It's not gonna be pushed back.
Okay.
Same place.
Yeah. All right. Sick.
All right, guys. Cheers.
Cheers.
See you, brothers.